Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss about ROM design, ROM. Right, previous class we discussed about SRAM, DRAM and serial access memories. Now let us see today what is ROM, ROM, read-only memory. So it is nothing but read-only memory. Read-only memory. Read-only memory. Read-only memory. So in this, we can only the read operation can be performed. Okay. So only read operation. Only read operation. Only read operation. Read operation. Right, only read operation stores 1 bit data in each transistor. Store 1 bit data, 1 bit data, 1 bit data in each transistor. In each transistor. Each transistor, mass transistor stores 1 bit data. Each transistor. Right, each transistor 1 bit data stored. So used in ROM applications are used in mobile. We can also use it in mobile computers, right? We can also use it in TV, washing machine. So stored only read operation can be performed. So mobile, computer, TV, washing machines, washing machine, AC. So these are the applications which are used for any electronic device, any electronic device. Any electronic device. So we can also use it in any electronic device, only read operation, only which can read the data. Okay, any electronic device, only read operation only. Read operation. If you want to write the data, we can use electrically erasable read-only memory. So EPROM, that is electrically programmable read-only memory. So these are the applications, and only read operation is performed in this read-only memory. Also we use also some flash memories. Also in flash memory, it is a permanent memory. Also in flash memories. Flash memory in a mobile or a computer, we use this flash memory. It's a permanent data storage. Flash memory. Okay, flash memories. Like we can also use DVDs. Okay, DVDs are the flash permanent storage. DVDs, right? DVDs are the flash memories which we cannot erase. So the advantage of this one, advantage of ROM is stored data permanently. Okay, stored data permanently, right? Stored data permanently. So even power of data cannot erase. Data cannot be erased. So cannot be erased. Okay, so this is the advantage of ROM. It stores permanently even though power of data cannot be erased. But whereas in RAM, if power of data will be erased. So that is a temporary storage. It is a non-volatile memory. So we call it is non-volatile memory. read-only memory is a only read operation which is non-volatile memory. Non-volatile memory. Permanent storage. Non-volatile memory. Non-volatile memory. Non-volatile memory is called read-only memory. So how can we design? Let us see the non-volatile memory. Okay, non-volatile memory. Let us see how it will be designed. How it will be designed. So let us see ROM design. ROM design. ROM design. Right? How it will be designed. ROM design. You can see this one. Let us, for example, it is used in row decoder circuit. Right? A row decoder circuit it is used. Let me see this one. You can see this one. You can see this one. It is a row decoder circuit. Three inputs are here. A, B, C. Three inputs are here. It is row decoder, a decoder circuit, row decoder circuit. Let us see this one. It is 1, 2, 3, 4, 5, 6, 7, and 8. So let us see this one. Outputs are 1, 2, 3, 4, 5, 6, 7, and 8. So we can take this, otherwise we can take 0 to 7. According to the address line, it will be taken. So 0, 0 address. So it is 0, 1, 2, 3, 4, 5, 6, and 7. 0 to 7. Total 8. Right. Let us see. The above one is above one. If you are using this PMOS, a PMOS, a PMOS. Above is PMOS design. Above is PMOS design. So each address, the data stored output. So 0, 0, 0. Then output lines are 3 to 8 decoder. It is a 3 to 8 decoder, like. So it is a 3 to 8 decoder. So VDD is applying, connected to ground. It is connected to ground. Okay, it is connected to ground. Above is PMOS transistor. PMOS transistor. So bubble across the gate terminal. PMOS transistor. PMOS transistor. This is a PMOS transistor where we apply VDD. Right, this is VDD. VDD we are applying. VDD we are applying. So here the output lines are, and take the output lines are D3, D2, D1, and D0. Right. So this one is D3, D2, D1, and D0. So four outputs are here. Four outputs. These are the data outputs. Data output lines. Data output lines. So according to the address are the input lines. Address are the input lines. So each address location, the data stored here. The data stored here. So let me take the transistors are here. The transistor over here. NMOS transistor is connected over here. Where the transistor is present, when the transistor is present, the data stored is 0. The data stored is 0. Right? Data stored is 0. So from here to here, like the transistor is present here, the data stored is 0. Data stored anywhere you can take. So means the data stored according to the data store. Right? Here different types of data stored over here. When transistor present, it will be 0. The remaining all data present and absent. The transistor is data present and absent. The transistor present is 0. If not present, it is 1. Present it will be 0, not present it will be 1. Okay, like you can take the transistors. So each address location data stored over here, right? So each address location, so 000, so it will be starts from 00 to 111. Okay, so the here the data line, the data path here it is. Let me take the, if you take the table over here, so ABC are the inputs, ABC are the inputs, data paths outputs are D3, D2, okay, D1 and D0. So what is the data outputs are here according to this? So we have 000, address lines, input address lines. These are the input address lines. So output data stored in the transistors. Permanently data stored, each address location. 000, it is a 3-bit address location. 000, 001, 010, 011, 100, 101, 110 and 111. Okay, so let us see this one. 000 means what is this? 010101. So the data is 0101, right? Now when it will be 1, 1 means 1010 1010. So 1010. Transistor present is 0. If not, it will be 1. Like 2 means 0111. So 0111. Okay, 0111. Now the next one, third one is 1100, 1100. So data stored 1100. Transistor present it will be 0. It will be remaining. It will be 1. Right. The next one, 100, 100 means 4. So 100, 1011, 1011. So 1011. Now fifth one is 1101, 1101. So 1101. Now the sixth one, 1010, 1010. Right, it will be 1010 data stored, right? The last one is 11, all are 11, there is no transistor present. Okay, so according to that, the data stored over here. So when the transistor is present, you see the VDD is passing through this one. So it is a pseudo NMOS connection. So PMOS is connected to VDD. The VDD passing through this one, it is connected to ground potential. It is connected to ground potential. When the transistor is present, so data stored 0. So otherwise it will be 1. So 1 passing through this one. So 1. So it is 0 and it will be 1. Now here also this path is 1. This path is 1 and this is 0 and it is 1 and 0. Here also 0, 1 and 1 and 1. So this is 1 1 and 0 0, right? 1 0 and it will be 1 and 1. It is 1 1 0 and 1. Here 1 0 and 1 and 0, right? The last one is 1 1 1 1. So directly the VDD passing through this one. So when the VDD passing through this one, when transistor is present, so it will be passing through this. When that particular is selection, when 00 is there, then the gate is on. The gate is on. The data means VDD passing through, it is connected to ground potential. So it is 0. When transistor is present, 0. So when transistor present and absent by selection of row selection, address selection. When transistor, right? When transistor present, so 0, logic 0 stored. So 0 stored, 0 stored. Okay, so otherwise it will be 0. So otherwise 0. So otherwise otherwise 1, otherwise 1. When transistor present, it should be 0, otherwise it will be 1. So according to the selection of this address line. So it is 3 to 8 decoder, 3 to 8 decoder. So 3 to 8 decoder, and it should out 4 outputs are here. So 3 to 8 output lines are there, and row is the, this row is represents the address, each address location. This is a row selection according to the address line. So according to this address line, then output row is selected, and column is the data output line, right? This is a ROM design. So ROM is a permanent data stored in these transistors, so zeros and ones. So each address location, the data stored. So data stored. So it is the structure of pseudo NMOS connection. D3, D2, D1, DT are the output data. So output data, you can also observe this in the table representation, where 0 is a transistor present, 1 is a transistor not present. So this is about ROM design of row decoder, right? Let us see the NMOS structure of ROM. Let us see the NMOS structure. NMOS structure. NMOS structure. NMOS structure. NMOS structure ROM. Okay, let us see NMOS structure ROM. Right? NMOS structure ROM. So here you can see this one. Let us see NMOS structure. Right? It is NMOS transistors are there above. NMOS transistors are here. Okay, and we can select the address lines. We can select these address lines. Word line selection. Right? A word line selection. So here the transistor present over here. When the transistor present, it will be stored 0, right? It will be stored 1. It will be stored 0 when transistor is present. Otherwise, it should be 1. Otherwise, it should be 1. Let me see this one. Right? The above one is a clock signal. Above one is a clock signal. Above one is a clock signal. Can take NMOS transistor is present. When the transistor is present, it store 1 bit 0. Right? Let me take one more here. And here is the transistor. The transistors are here connected to the second clock. The two clocks are here. Okay, so it can be design of ROM by using NMOS structure. You can see all these are NMOS transistors, right? NMOS transistors. It's a ground connection. This is a ground connection. This is a ground connection. So this is going to the VDD, right? This is going to VDD. The path is going to VDD. Right, here also one transistor is connected. This is a ground connection. So let me see, this one is a pi 1 or pi 2. Okay, second clock, and this is pi 1. Okay, we can connect the VDD passing through this one, VDD connection over here. So we can take the word line. So word line 0. Okay, word line 1. word line 2 and word line 3. Okay, word line 2, word line 3, 0, 1, 2, 3. Right? So according to the selection of this one, the selection, according to the word line selection, the data stored word line selection, are the address lines. Word lines are the address lines. And the column lines are bit lines. The column lines are bit lines. Right? So let us see this one. When the transistor is present, the output of here it is. So it is transistor is present, then it will be connected to the ground potential. So path established. So the VDD passing through this one. When word line selection, the gate transistors are on. Word line selection, gate transistors are on. So data through this data through this transistors, the above transistors means VDD passing through this one through drain and source. Then it will be connected to the ground potential. So it is stored the 0. So it is a 0, right? 0, 0, 1, 0. Okay, word line 0. Now word line 1, here it will be, there is no, so it is 1, 0, 0 and 1. Then the data path. Word line 2, the data stored here. So transistor present is 0. NMOS transistor present is 0. 0, 1, like 0, and this will also 0, 1 and 1, 1 and 1. So here one, this one. So it is 1. Transistor is present, data connected to the ground potential. So 0, 1 and 0. So this is a data line. So data stored, data output line. So data line. This is the data line. This is the data line. Data line, word line is the input address locations. Input address locations. Input address locations. According to the input address locations, right? Each address location stores 0010. When transistor is present, the word line is high. So gate transistors, all the gate terminals are on. All gate terminals are on. So when this will be the pi 1 is the clock input clock signal. So clock signal, we can say the clock is applied. The above transistors are pre-charged to VDD. Okay, so VDD, it is charged, and this VDD passing through this one. When the gate is on, the VDD passing, it will be stored to the ground potential. It will 1. So VDD is passing through this, it stores the 0. When transistor is present is 0, and transistor is not present, it will be 1 bit data stored. So when word selection, all gate terminals are on. So gate terminal is on. So this is a gate, source and drain terminal. Gate, source and drain terminal. Right? Then data path is passing through this one, which will be connected to the second clock. So clock 1 and clock 2. Clock 1 and clock 2. Right? Given to this another NMOS transistors, another below NMOS transistor. So pi 1, pi 2 are the, so two phase clock signals. Okay, two phase clock signals. So one is the source is connected to the source of this transistor, and another one is connected to the drain of this transistors. Okay, right? So two are the clock signals. So clock 1 and clock 2. And word selection, according to the word selection, the transistors are on. The data through this is connected to the ground potential. Data is connected to the ground potential. Right? Now word selection, according to the word selection, 1 bit data per transistors. So word selection, transistors are on. Transistors on. Transistors are on. When transistors are on, when transistors are on, so data connected to ground potential. Data connected to data connected to ground, data connected to ground using pi 1 and pi 1 and pi 2. So pi 1 pi 2 clock, pi 1 pi 2 clock signals. So there is a static power, there is a static power through the transistors, static power through the transistors, static power through the transistors, right? It is a permanent data storage transistors. So static power from pi 1 to pi 2, so pi 1 to, so for VDD, so when clock is applied over here and the clock is applied over here, so below transistors are on, above transistors are on. So the word selections, word is a address locations, address location 0 1 2 3 address locations. It will be selection, the transistor gate terminals are on. So data from VDD, it is connected and it is passing through. When VDD passing through this one, when the gate pi 1 pi 2 are on, then clock pulse is applied. So this will be passing through source and drain. It will be connected to the ground potential, it will be connected to the ground potential. You see this one, when the transistor is present, is 0. I want to tell you this one, transistor present, transistor present, transistor present, transistor present bit, so logic 0, so 0 bit stored, you can say 0 bit stored, 0 bit stored, 0 bit stored, 0 bit stored. So otherwise logic 1, so otherwise logic 1 stored, so logic 1 stored. Okay, so this is a ROM structure. So ROM structure, m input lines, let us take n address lines, m output lines, m bit lines. We can see these are the bit lines, 1 2 3 4 bit lines. So these are the bit lines, we can say these are the bit lines, right? Column are bit lines, n are the address lines. So this is address lines, so the column are the bit lines, you can say these are the bit lines, bit lines. So m into n into m matrix, n into m matrix, n into m matrix connection, n into m matrix connection, matrix connection, matrix connections, right? Like this type of transistors are stored. So n into m transistor connection, right? N is a address lines, m is a column lines, data lines. So n into m matrix connections. So this is happened in ROM NMOS structure. Let us see the another ROM structure, another, let us see CMOS ROM structure, CMOS ROM structure. So in NMOS ROM structure, there is a static current flow from VDD to the ground, pi 1 and pi 2. Two phase clock signals are applied according to the word selection. Now in CMOS ROM structure, CMOS ROM structure, so only one phase clock is applied. So there is no static power. Let us see this one. Let me see this one. So it is only one phase clock is applied. One phase clock is applied. Right, only one phase clock is applied. One phase clock is applied. You can see the word selection, the data transistor, one bit is stored. When transistor is present, here it is one bit is stored. Right, we take this is a VDD. Right, this is a VDD. Okay, so and another one is a word selection. When the transistor is present here, right? So this is connected over here, right? This is a VDD. So it is a PMOS transistor. PMOS transistor. You see this one, ma? This is a PMOS transistor. PMOS transistor. So word line 1, word line 2, word line 3 and word line 4. You see this one. So word line 4, word line 4. When the transistor is present, here stores the 1 bit data. It stores the 1 bit data. So it is a PMOS transistor which stores 1 bit data. Right, let me see this one. And also let me take over here one more transistor. So previous in NMOS transistor is present, the bit stored in 0. Transistor present is 0. Here transistor present is logic 1. So replacing the pi 1 complement, right? Pi 1 complement. So this is pi 1 complement. So all these word lines are pi 1. So pi 1 is equal to low here. Pi 1 is low. So pi 1 is equal to low. Pi 1 is equal to low. So only one single clock is applied. Okay, the single clock is applied. Now what happens? VDD passing through this one, right? What happens here? And the PMOS transistor. PMOS transistors are here. It is a CMOS, NMOS. So this is NMOS. This is NMOS, and this one is PMOS. PMOS transistor. PMOS transistor. When transistor is present, so the row selection. This is a row selection, means address lines. According to the address, the output address lines are connected over here. So row selection, each row stored the bit, 1 bit each transistor, each row. So according to the number of transistor columns, then the data stored, each transistor 1 bit data stored. So row selection, it is a row selection, ma. Row selection. The gate terminal is on. So gate is on. The VDD is connected to 1. So VDD is connected to 1. So VDD is passing through this one. It stores 1 bit data. When transistor present, here it will be 1. So transistor present 1. Okay. This is 1. And this is 1. And this is 0. And this is 0. Okay. Transistor is present. Otherwise it will be 0. 0. And this is 1. Okay, bubble, right? And this is 0 and 0 ma. So it is 0 0. Transistor is present here, it will be 1 and it will be 0. Transistor is present, row selection. So gate terminal is on, then VDD is connected. So it will be logic 1 stored, logic 1 stored, logic 1 bit is stored. So otherwise it will be directly connected. Otherwise it should be 0. Otherwise it should be 0. So row 1 selection. So row 0, we can say row 0 selection, it will be how much data stored? 1 1. 4 outputs are here, 1 1 0 0, 1 1 0 0. So row 1 selection, how much it should be? 0 1 0 0. So 0, transistor is present here, 1 0 and 0. Okay, now third one is how much it should be? 1 2. So row 2 is how much? 0 0 1 0. So 0 0 1 and 0. And third one, last one is third row, it is 0 1 0 0. So in the CMOS structure, so no static power dissipation. No static power dissipation, only single phase clock is used. No static power dissipation. No static power dissipation, ma. No static power dissipation as in NMOS structure. Dissipation, no static power dissipation. Okay, only one single phase clock is there. Single phase clock is there. Single phase clock used. Single phase clock used. Okay, so and transistor present. When transistor present, it is a PMOS transistor. Transistor present, logic 1 stored. Logic 1 stored. Okay, transistor 1 present, logic 1 stored ma. And when transistor otherwise it will be otherwise, okay, otherwise logic 0 stored. So the this is about the ROM structure. Okay, CMOS ROM structure, it is NMOS and PMOS. When PMOS row selection, transistor present, 1 bit data stored. Otherwise, it should be 0. Okay, and NMOS structure, in NMOS structure ROM, so the data column is a data stored. Okay, horizontal is a address line selection. When here transistor is present, 0 bit stored, otherwise it should be 1. Okay, and we are seeing this ROM design, so it is a decoder, row decoder selection. According to the address line, the output lines are stored. Transistor present, NMOS transistor present, it will be data stored is 0. Okay, so ROM is a permanent data storage. Okay, it stores 1 bit data per each transistor, so which is used in flash memory. Okay, so please, thank you. Please subscribe the channel. Okay, inform to your friends, like. Okay, thank you.